Hello, in this session I'm going to talk about how to perform Houseman test, whether fixed or random effect model is the most appropriate to use. A random effect estimation is the assumption that random effects are uncorrelated with the explanatory variable. One common method for testing this assumption is to imply Houseman test to compare the fixed and random effect estimates of coefficient. Now the model we have to apply are fixed effect, as you can see it here, fixed effect, or we call it LSD V model, or random effect model. Then we have to use correlated random effects Houseman test. How to construct the general model of the panel data. Here the panel data analysis, we have time series YT equal alpha B XT and error. Cross section we add I for different country, YI alpha beta XI error term for our disturbance term EI. Panel data we have to combine both of them, YTI, XTI and ETI. As you can see, this is the general form. Why we use it, the panel data, because there is regional analysis is required and the data is not enough for individual analysis. So the panel data model to be estimate may be given by the general form as we mentioned here. This is the general form for panel data and use it here, where treated as AIT as fixed or random if AIT is independent variable or explanatory variable, or AIT does not correlated with the explanatory variable. This is the null hypothesis, or AIT, which is alpha IT, is correlated with the explanatory variable, which is HA. From this we can see which model we can or we have to apply: fixed effect model, random effect, and the answer Houseman test. Then here the Houseman test hypothesis. We have null hypothesis, random effect are appropriate or most appropriate model, which means that if we cannot reject null hypothesis, it means the random effect is the most appropriate model. Or if we reject null hypothesis and accept the alternative hypothesis, this means that fixed effect are most appropriate model, which means that null hypothesis is not true. So let us go to the panel data. We have the variable, as you can see, logarithm GDP EE, GDP PE, and logarithm EC and logarithm CO2. We want to estimate the relation between the dependent variable log GDP E and two independent variable log EC and log CO2. The data cross-section data from 2000-2014. Now we estimate the three model one by one. We have taken 6 country, 1, 2, 3 to 6, and the 3 variable of each country. Now we have to go to eViews and open the data. This is the data here. We have to select. This is the ID for the panel data, and this is the dated, which is the number of years we use for each country, and then this is the 3 variable logarithm GDPPE, logarithm EC, which is energy consumption, and logarithm CO2. We'll open it as a group, and here the data, you can see it, the data here. This is the, as you can see it, there is country 1 from 2000 to 2014. And this is country 2 from 2000 to 2014 up to here. And this is the country number 3, and this is country number 4, and this is country number 5, and this is country number 6. So we have 6 country with the 3 variable, and then we have to do the analysis. How? I want to run the fixed effect and then random effect. Then we have to get the right answer for which one is more appropriate, fixed or random effect. I have to go to quick estimate equation, type the variable logarithm GDPPE constant logarithm EC logarithm CO2. This is the variable we use in the model, and this is, we leave it as it is, that the year 2014, and then I have to go to panel option, change it to fixed effect, and then leave everything as it is, press OK. This is the outcome of the fixed effect model. Then we have to estimate random, we leave it as it is, we go to panel, and then we change it from fixed to random effect, and then we press OK. This is the outcome of random effect model. But which model is the most appropriate? The answer with Hausman test. So we have to run or perform Hausman test, and how? I go to view, and then random fixed random effect testing. I go to correlated random effect Hausman, and then we can see this is the probability. What does it mean here? If I go to the hypothesis, here we said null hypothesis, random effect are appropriate model, and alternative fixed effect are appropriate. So what does it mean? If we here we cannot reject null hypothesis, as you can see, a cross section random, the chi-square 53.11, and the degree of freedom 2, the probability 76.68, which is greater than 5%. This means that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that we say the random effect model is the most appropriate model. So in this case we have to run the random effect model again, and then we test for the normality. How? I go to estimate, panel option, random effect, and then press OK. This is the random effect model, and then I go to view, then fixed random, residual diagnostic, histogram normality. As you can see it here, this is the histogram normality, the Jacobra 54.43%, the value, and corresponding to p-value 76.17%, which means that greater than 5%. This means that the residual are normally distributed. And this is a short video how to perform the Hausman test. First we have to run fixed effect model, and then we have to run random effect model, and then we have to run to perform a Hausman test to see which model is most appropriate. Then we test for the normality. Thank you so much, and please subscribe for more video